Hello everyone, this is Maurizio, editor-in-chief of Power Electronics News, and welcome to Wind Down Friday. Today, our special guest is Dick Otte, CEO of Promex. Hi Dick, thanks a lot for being here. How is it going?
Good morning. I'm pleased to have an opportunity to talk with you and address your audience.
Thank you. Thanks a lot. It's a pleasure. So where are you located, Dick?
My office is in Santa Clara, California. Here, although the company has got a second facility in Escondido, California as well, but California based.
Nice place. So, Dick, let's start. So, I would like to know more about your career. How did you start your career, your first job?
Basically, I'm an electronics engineer. I have a BS and MS in electrical engineering. I spent 5 years working for a small company outside of Boston on Route 128 in the early days of semiconductor. I went to the Westinghouse Research Labs and worked on television systems. They were trying to compete with RCA's shadow mask system and learned a lot about that. Got very annoyed with the Westinghouse management and did the thing I swore I'd never do, which is to go get a degree in business administration, which many of my fraternity brothers had done. And my motivation in doing that was to understand the world in which technology was used. How were decisions being made? How did money and personalities and organization influence how technology was developed? So when I was in business school, I sort of saw myself as a spy. I was a technology guy there trying to understand how the upper management made their decisions here and I really chose getting an MBA over a PhD. The company I worked for at the time was pushing me and offering to support my getting a PhD, but I had been so annoyed by what I saw from a business perspective that I felt that it was more important to understand the broader context in which technology was being used.
Mhm.
Now, you have to understand that this was in 1967, 68. In that time frame, it's quite a while ago when semiconductor was just emerging. Like when I was in school, I built devices using a CK722. That is the first transistor ever put on the commercial market. And so I've seen the entire evolution in my career of the semiconductor industry. The first devices that I built when I was a practicing engineer used 6SN7. That's a vacuum tube. And so I've seen the whole thing and watched it all mature across the years. Anyway, I got out of business school. Instead of staying in electronics, went to work for a company in Menlo Park, California named Raychem that was specialized in utilizing unique materials to develop products. And my role there was to develop products for the electronics industry. And I ultimately spent 20 some years working for them. The last thing I did for Raychem was to run a joint venture they had with Corning Glass called Advanced Packaging Systems. That was here in San Jose, California. And we had a second facility in Southern California in San Diego called Interamics that built ceramic components. And we were trying to build what in that stage of the industry's development were called multi-chip modules.
Mhm.
Now this was in roughly in the 90s that we were doing this. And what I learned there was that the future of electronics was in physically small. Everybody knows about Moore's law, and that trend and that he described continues to this day to drive much of electronics and much of technology on a broader sense. We have learned that as Feynman said in that famous talk he gave, there's lots of room at smaller sizes than the bottom. And I'm paraphrasing him poorly, but that phenomenon continues to drive and more functionality per unit volume in not just electronics, but in all of our technologies continues to emerge. And the devices and the capabilities that we are able to fabricate now are continue to get smaller, and we are looking for the trends now that are important here and that are emerging is how do you build these things? You know, that traditionally we make individual parts and we put them together. That's basically what my company, Promex and QPT, we both do. We get parts and we put them together. The semiconductor industry doesn't do that. They lay down material, then subtract what they don't want. Lay down the next layer, subtract what they don't want. So that's a second way of building things. Now, if you think about it, Mother Nature does a third thing. She runs fluids about through a bunch of tubes and through osmosis, through tissues, and deposits things at specific places. And it's sort of built up, it's a kind of a funny combination of things. And as things get smaller, this business of taking parts and putting them together gets tougher and tougher. How do you join them? Why do they stick together? All that kind of stuff. So I see an evolution toward 3D printing and more complex versions of 3D printing, where multiple atoms and materials of different composition are put down with increasingly high resolution. It's clear to me we're going to be into electron microscopy to manage and control much of this stuff. It's becoming viable over the next 20 years. I mean, these are long-term kind of things. This isn't going to happen soon. Nice. But there's just and we see increasingly small things now. We've got 3 projects in house here that we've done in recent years, where we make a medical device that's injected into the body with a hypodermic needle. And some of these parts that we're injecting, they've got a dozen parts in them that are less than a millimeter apiece. So
nice.
That is a powerful trend here that's driving a lot of this sort of stuff. Yeah.
So let's talk about current trends in electronic and microelectronic assembly technology. So how do you see these trends shaping the future of the industry? What key challenges, opportunities so what are these ones that come with the continuing evolution of this the technology? Maybe you can also explain, you may explain the importance of developing technology roadmaps in the context of optical data transmission.
Yeah, let me deal with those separately. They're 2 topics. The trends that you are here, the most recent trend that's driving this small stuff is the introduction of the chiplet concept. Basically, the chiplet, the difference between a chiplet and a conventional IC is the power of the output devices. They do not, most semiconductor chips have got enough power that they will drive a few centimeters of wire. Chiplets don't. Chiplets, you've got to communicate with them over a couple of millimeters, and that's as far as it'll go. The reduction in the drive power, of course, saves power, saves space, and what have you. Chiplets will be a key part, a key emerging component. They help achieve great density. Putting them together utilizes these new technologies that go down with IOs on pitches as low as 1 micron. That is now being done here, and some of the devices that are being commercially sold now have got IO pitch utilizing what's called hybrid bonding down to 5 micron pitch, maybe less than that. It's hard to know what the state of the art is, because the people that are doing this stuff don't really always tell you exactly what the details are of these things. But it's clear that's the direction that we're going to go with more and more of these vertical integration. And we're more and more building in the 3rd dimension with these devices here. Interposers utilizing organics are clearly going to continue. So I see that as an important direction. Now, to save power, there's a lot of interest in optical technologies. And the optical technologies have emerged over the years. We continue to struggle with how to build optical devices and combine them with electronic devices. There's been a lot of work done over the years. Bowers at UC Santa Barbara has been a real leader in that, and he's proposed some good solutions. There's an interesting paper written by Bowers, Levinson, and Hochberg, I think, here, that talks about the future of photonic integrated circuits and how they're likely to be based on silicon nitride, which is very interesting. It has an unusually low loss factor, and that from what I know, what that paper proposes is more likely than anything else to be the future of photonic integrated circuits. The issue is where do you put the laser, and how do you integrate it with the logic and interface it here. That's the issue that everybody is struggling with. Some people, like IR, for example, believe in an off-chip the laser. The laser is separate. People are doing that. It's because that allows you to control the temperature and hence wavelength very nicely. It allows you to get the heat out of the laser without messing up everything else here. Other people feel that you got to integrate it all together. We will see how that emerges. And this is where roadmaps come into play. The roadmaps are developed by people who understand these technologies, and fundamentally they are proposals of the ways and the direction we can go with our technologies, and make an attempt as best you can to describe the pros and cons of each of these approaches. And they tend to be more technically oriented, don't really look too much at what I'll call the commercial issues and the economics sometimes here. And the first thing, it's got to be technically viable, or it isn't going to go, of course. And then the roadmaps help address that second set of questions. This is technically viable. Now, what is commercially viable here and economically viable? And those issues are really critical in today's environment and world where everybody is conscious of what things cost.
So, as the philosophy of Wind Down Friday, so I would like to ask you, beyond your job, so which are your hobbies? So what you like to do beyond your job? So hobbies, play guitar, so reading scientific books, reading papers. So tell me more about your hobbies, Vic.
Yeah, well, let's see. Physically, I'm big on hiking. In my younger years, I was a runner to the point in my life where that's kind of getting old. So I'm a hiker, and that's my main mechanism for getting recreation and staying in some kind of physical conditioning, controlling my weight. In reading, I have two things I read. I read books and I read periodicals. I have what I will call an old guy style list of publications that I read in hard copy. You know, like,
do you have a copy?
Just today's paper. I subscribe to the San Jose Mercury News, the Wall Street Journal, the New York Times, Scientific American, The Economist, Fortune magazine, etc. And I go through all of those to some degree or another, and a whole series of. I probably have subscriptions of hard copy stuff to maybe 15 to 20 things, and I go through them to some degree or another. I'm trying to convert some of them to electronic online, but I don't find that as easy, and I'm not drawn to it, if you will. So yes. Yeah. The second thing I read is books. My wife and I belong to a book group, and that has us reading all kinds of what I will call odd things. There's the most recent thing we're reading is a book called The Journey, which is a story about some people from the Middle East and how they have been driven around the different countries there by the social issues of that part of the world and the implications. And that's the absolute, totally 180 degrees away from the other world I work in. I also read science fiction, although I must admit in recent years I have found real science more interesting than science fiction. It's astronomy is one of the publications I get that sort of makes an attempt to keep me in touch with what's going on in the broader world of cosmology.
So let's back in your career. So you mentioned your MBA instead of PhD. So how has your MBA influenced your approach to technology, to innovation during your professional journey? And maybe please tell us about a project and achievement that you are particularly proud of and why.
Yeah. Well, let's see. The way the MBA allowed me to really pick up and run my own business. I would not be sitting here running and owning this company if it wasn't fact for I got an MBA. You had to understand something about finances and balance sheets and all of these other kinds of things to be able to put this together. Now, that's me. I know other people who have not got MBAs that run businesses very successfully.
Mhm.
But for me, it was an essential thing given my background and where I came from here. A key program, boy, I'm hard pressed to know what to talk about. I think the most important thing I ever did was a thing I did when I was my first career as a young engineer. I developed a device, uh, a device that was classified, and I think to this day should be remain classified. That was really, I think, maybe one of the most important things I ever did. In recent years, in my late years with Raychem, we developed a whole series of interesting products based on the memory alloys, the nitinol, and there's a material called beta phase out
Mhm.
there that's another material that has. We developed a whole family of things. I ran the memory metal business that Raychem had for roughly 10 years here, and the most important success we had was developing a connector that went into the inertial guidance systems of the Minuteman missile system. We sold tens of millions of dollars worth of that product here, and it had some very unique characteristics
Mhm.
here. It was a zero insertion force multi-pin connector that had no particles and no dirt. The inertial guidance systems are highly sensitive to particles for various reasons that I'm a little vague on. So that's probably the most important commercial thing that I was ever a major participant in, but certainly not a sole participant. That program was a big activity for many years within Raychem that required a lot of individual people to accomplish
Okay.
it.
Okay. So the last one, Dick, my last question to conclude. So just a comment. How do you see the future of technology in general? So tell me more about your perspective for the next years, I can say for the next 5. Let's stay step by step. How do you see the future?
Well, we are dominated today by applications and enhancements of artificial intelligence.
Yep.
Uh, that's the thing which is really driving much of the chit chat and thinking about where to go next. How do you incorporate artificial intelligence into your day-to-day things? How do you support it with technology and hardware communications? Um, that's where a lot of energy is going. I think also 6G communications,
Mm.
shorter and shorter distances, greater and greater bandwidths. Those are really going to be critical here as well. I think that we are also going to experience a lot of what I will call fusion, the combination of electronics and information with the biological sciences and the physical sciences.
All right.
More and more, the people in the biological and the life sciences are understanding the value of utilizing electronics, especially since much of life operates with neurons
Mhm.
and these kind of 10th volt kind of signals there. And electronics is going to be more and more incorporated to capitalize on those kind of things. The other thing I think we've got a major issue shaping up with is what do we do about power? My personal view is that we should be building nuclear power plants at an incredible rate to generate electricity. If you have electricity, you can charge your electric vehicles. You can use them to replace electricity to replace a source of heat generated with fossil fuels and get out of this carbon stuff. Get out of burning fossil fuels for more, not only to reduce the carbon footprint in the atmosphere and the implied global warming, but also to just simply save the natural resources for other purposes here and here. So I'm a big proponent of nuclear power. To me, that's one of the most important things we've got going here. I think it's really been unfortunate for the last 50 years. We have put nuclear power on the sidelines for reasons that's a whole nother story here
Yeah.
about what got put on the sidelines. Yeah, but I think it's being resurrected. I'm quite pleased to see some of the major companies here now paying for building and having small nuclear power plants built here for them. The U.S. Navy has shown for 50, 60 years now that you can do this. They've got a fair number of reactors. They've run these with great success over the years. They have developed the technologies for that class of device very nicely. And I hope now that we get on with doing it for sources of commercial power here as well, and utilize it to supplement the renewables like wind and solar. So,
Right. So Dick, thanks a lot for joining us at Wind Down Friday. It has been a pleasure to talk with you. Thanks a lot.
yeah,
I wish you a great weekend and see you
yeah.
next. Thank you.
Thank you. Bye now.